So welcome to my presentation today. We're going to discuss about the uh, synoptic meteorology, the part of the synoptic meteorology. In this lecture, we're going to discuss about the air masses, and we'll also discuss later part of this chapter about fronts. First of all, air masses. What do you mean by that? Air masses is a chunk of air which has same characteristics within its territory. That means its different characteristics such as temperature, humidity, all are same in a chunk of air. It can be, as I said before, it can be 100 kilometers to 1,000 kilometers also, and during all its position, relatively the nature of that air masses is same. And during the journey of the air masses, it can overpass different sources, different land uses, and it can also changes its behavior a little bit. But normally the sources where it has been originated, it can possess those characteristics with it. Once it has been formed, on it has been relatively have a stable condition, then it migrate within the general circulation pattern. That means it moves through the general circulation pattern. And upon movement of these one, when they displaces the residuals air over different locations, they can also change their characteristics a little bit, but normally they have their own characteristics to others. And this is also important because they also changes the different environmental conditions of different locations. For example, in one location which is prevailing with some kinds of air before, so when from other areas some other air coming on that positions, they also changes the local environment with their characteristics. So how we can differentiate that, how we can classify them? So basically we know that all over the world we have two different main land uses, two different types of surface. One is we have water, another is land surfaces. And we know the water surfaces is more than the land surfaces. So if any air masses originated has been originated from the water bodies, we say this is a maritime air mass. On the other hand, if any air masses which has been originated from the land surface, we say this is a continental air mass. This is broadly two different sources. Now, if we can see whether the location is on the in which latitude. Is it in the middle of the latitude? It is in the tropical region or polar region. So depending on different latitude, we can also segregate it another three types. So if it is in tropical region, and the tropical region is in the water sources, on the water sources, so we say maritime tropical, and we denoted it as a smaller m and capital T. On the other hand, if you just travel a little bit upper area, that means in the polar area, and if the surface is water, we say maritime polar area. And similarly, if it is a continental area, continental surface, and if it is a tropical area, we say continental tropical. In polar region, we say continental polar, and Arctic region, we say continental Arctic. Normally, we don't say maritime Arctic because in the Arctic region, all over the year they are actually covered with ice sheets, and thus we normally take it in account as a land surface, as it's not behave like water. So they are like the continental Arctic in as a whole normally. If you see this figure, you can see these are the white colors area which is denoted as water. That's why we say this is maritime. And if you see the this, if it is 0 degree latitude, that means the tropical and subtropical region. That's why it is named as MT, that means maritime tropical. So the smaller letter is denoted as the source of surface, and the capital letter is the source of location. So maritime tropical area is, maritime means water and tropical means it is by the side of 0 degree to 30 degree latitudes, both north and southern way, southern hemisphere. Uh, if you go a little bit upper area, you see this two one MP, that means maritime polar. That means they are started with from 30 degree to 60 degree, these latitudes, but they are of the surface is water. If you see this gray color area, this is our land surfaces. These land surfaces, sorry, if it is on the tropical areas, we say continental tropical, this one, little bit upper continental polar, and in the Arctic region we say continental Arctic. And we say continental Arctic because this ice sheets is remaining as a ice all over the year, so it behaves like land surface. That's why it is continental Arctic. Why you differentiate with this way? Why don't we take in account in other ways? Because because the air masses, as I said before, they have two different characteristics. One, there are many characteristics. They have many characteristics, but mainly they poses two main characteristics. One is its humidity. So we know humidity is dependent on the water. Humidity is dependent on the source of water. So those air masses which is originated from the water surface, as a maritime we say, they possess a more humidity, and those air masses who originated from the land surface, they have less amount of the humidity. So that's why you differentiate like this. Another way, yeah, another important factor is temperature. So temperature in the mid latitude is little bit more than the polar, and they have more latitude, more temperature than the Arctic region. That's why you also differentiated with the latitudinal distribution. uh, these gauges, temperature and humidity, are the basic characteristics of air masses. That's why we differentiated with on the basis of the humidity source and on the basis of the temperature source. Now this is a wider view how we can see different sets of air masses, regions from where it has been originated. So this is our 0 degree latitude. This is in the middle. So both the sides of the 0 degree latitudes, we have continental area, sorry, tropical area. And these tropical areas includes many different sets of oceans and also continents. That means land surfaces. So in between these two one, this is all over the Atlantic Ocean. By the side of this one, these are Indian Oceans. Okay, and the right side and left side, if you think as a, this is a globe, so this one and this one is Pacific Ocean. So these huge areas, if you see 0 degree to 30 degree north and 30 degree south, these whole areas from where if the air masses has been originated, we termed it as a maritime tropical. Okay, uh, maritime tropical, and their nature is definitely that will be different because most of the cases the tropical regions got the higher amount of the get the higher amount of the energy from the sun. Similarly, if the air masses which has been originated from this area and from the land surface, so there are a couple of land surfaces in here, so they have different characteristics. So I'm going to explain now each of the air masses depending on their locations, because we need to know these basic types of the air masses so that we can understand what type of characteristic they are going to be possess. But before that, one thing should be very important, that why air masses is very important in our weather phenomena. Why? Because you know when air masses, as it is a very chunk, very big area which is covered by each of the air masses, a chunk of air, as I said before, it is more than sometimes 1,000 kilometers, and that's why these air masses possess huge amount of the energy. Energy is a source. Energy can be stored in different ways inside the air masses. It can be stored as a water vapor. It can be stored as a other types of precipitation factors, or it can be also stored as a watery liquid substances inside the clouds. So that's why it is very important when air masses moves, masses moves from one place to another, actually it carries a huge amount of the energy, and then they are very much influencing the weather phenomena, such as different precipitation types, and also some instability. So those instability are also associated with these air masses. For example, if a air mass is coming from this region, polar or Arctic region, to the downward, we don't expect they can be very unstable. They can create any cyclone or anything. But if any air masses which is coming from this area, Indian Ocean or maybe from here, so those air masses can give you the idea that they can possess a huge amount of the energy, and they can create some cyclonic event on the bank of the coastal areas. So that's why air masses is important. This also creates the favorable condition for different seasons. A good example is from different desert area, when these for example this African desert area, when they can be produces some air masses, they can move long way to the Europe. And as we know, Europe is a little bit in a cold temperature, but during the journey of these air masses, which is originated from the Africa, they goes all the way long, and finally they create some influence on the summer in different European countries such as Great Britain or any others. So what I wanted to mean that this is very important for the local weather for each of the country or each of the geographical locations. Now, before I explain, I should give you a little bit idea about each of the broad section of our classification of our air masses. If the air masses has been originated from the continental sources, that means if it is originated on the land surface, we can expect that that type of air masses is dry in condition, whether it may be from Arctic region, it can be from polar region, or it can be from the tropical region. All of them are, they should be dry in nature. Okay. And then if it is from Arctic region, then that should be very cold. The polar region, they also cold, but not too much, not as like as the Arctic region. And from the tropical region, they should be not too cold, they should be hot actually. And that's why they can create some unstable condition in there. High humidity can be associated with that type of air masses, and surely they can create some unstable nature. On the other hand, if the air masses has been originated from the water sources, that means from the maritime locations, then then they are habituated with high amount of the moisture. Even they are from polar region, but they are very moist because they are originated from the water. And as they are moist, and if they move to any direction, they take these moisture with them, And with if it is originated from the tropical region with the moist condition, they have also a warm temperature, which creates some unstable condition in most of the areas. So this is the basic idea of the air masses. This is a figure of United States, just to make you a quick understanding. A country, US is a very big country, and you can see many different direction the winds are moving, the air masses are moving. So this is maritime tropical. That means the air masses which is created from the sea, from the ocean, yeah, from the Pacific Ocean. This is from the Atlantic Ocean, and these are red in color because they are coming from the tropical regions, and that's why they have more temperature than others. And that's why when they moves, they have high humidity with them and hot temperature. Due to that, in these cases where it meets with others, in each of the cases they can produce huge amount of the rainfall or precipitation because of its origin. On the other hand, you can see the blue color, which is coming from the further north and side of the north. This is maritime polar area, which is coming from the Atlantic Ocean. This is Pacific Ocean, and this is from Canada and Greenland and many and Arctic region. All the way when the air masses is coming from these directions, they are all of their nature is they are very cold in temperature, and these cool nature gives them a stable condition. Okay, and they don't have yes, the maritime polar area, they can give some vapor in here, but with this cold temperature they are not too much unstable. So this is the basic idea of the air masses. Now we are going to describe a little bit about them. So air masses can be distinctive due to its many characteristics. So I explained temperature and moisture, but rather than that, they should also be modified, or they can be characterized with some of the other properties, such as their changes of lapse rate, their stability, that means how stable they are, what is the local weather condition, and what would be the visibility during a course of air mass movement. So these all are associated with some characteristics. So if I now explain the merit each of the air masses, I'm not going to explain directly from the slides, but just to make you understand, you can understand the location of each of them, and so that you can also give your valuable understanding and comments in here. So first of all, maritime tropical. So maritime tropical, as I said before, this is the area the sun rays are falling very directly, and the temperature is high enough through all over the year. And that temperature gives them the evaporating condition so that they can be evaporated very nicely. And these evaporation makes them in unstable conditions, first of all. Then their temperature is high, and this can be seen by the side of the Latin America. These are the areas, and by the side of the Africa, most of the region of the Africa, and also part of Asia. That means the South Asia in here. So these are the by the side of this area. They are influenced by these maritime tropical air mass. On the other hand, if it is from the continental areas, the same thing, but the same area, but the surface area has been changed. Now it is uh, continental area. Then it includes whole of Africa, whole of the South America, part of the South America, actually, not whole South America, and a part of Indian subcontinent, China, and Middle East. So these are the areas where you can expect, and part of Australia also. So these are the areas where where the continental tropical air mass can be prevailed. And these characteristics of this one should be less amount of the that high temperature. They also possesses a little bit of humidity, but not too much, because they have originated from the land surface, and land surface don't have enough capacity to create an unstable conditions normally. So they are habituated to it like that. Now, if you go little bit upward, that means in polar area, 30 degree to 60-degree latitude, you see this is Atlantic Ocean. So in between that, on side in the right side, this is Europe, and left side this is North America and North America, Canada, and also part of Greenland. And these are the areas where the temperature can be very cold, but they have also possess the humidity. Similarly, these two portions, these are Pacific Ocean, and they create different conditions in North America and part of Russia, so that they can also be influenced by them. In polar region, if you just look up the land surface, this includes Europe, okay, and then most part of Russia, okay, or maybe Mongolia and others little bit. And on the other, in North America, America, USA, and Canada is in there. So their characteristics is they are much colder than the maritime polar area, but again they don't have any types of humidity condition, because they are produced on the land surface. And finally, if you go to the Arctic region, we normally classify them as a continental Arctic area, because most of the year round they are under the frost area, under the ice sheets, and that's why their characteristics is fixed as a land surface area. So now you can imagine those countries where it has been originated and how they can change their nature. One thing should be mentioned, that once it has been originated, it has these characteristics. But when they mix up when they meet with other type of air masses, they can change their behavior. This is very natural, and we're going to discuss about in fronts. When we're going to discuss about fronts, we'll discuss that. So this is all about the air masses, how it moves, what are their characteristics, and how it has changed the natures. So that's why in different areas of this country, of this earth, we have different sets of characteristics of the air masses. Uh, this is There are many other. Someone asked me, what do you mean by CAA? Actually, this is all over. I took this picture from Wikipedia, but the description is not from Wikipedia. There are many other types of air masses, for example, ME and others. So don't go for them. We are just concentrated about the basic types of the air masses. This is Antarctica actually, continental Arctic. We say continental Arctic and continental Antarctica. So here there is no population in here, and air masses has been characterized differently, so that we don't actually discuss about much of the Antarctica portion. And when they moves in different direction, actually they don't create any big changes, because when they moves all over the Indian Ocean or Atlantic Ocean and Pacific Oceans, again they change their behavior. That's why they are we don't normally classify them under that. But when we say Arctic, then this can also be included in these portions, because this is also ice sheets, And from these ice sheets, we have very cold temperature with less amount of the humidity. Okay. Now these are the explanation of different air masses, and they have changed their characteristics depending on the locations. So in your exam, if it will come, what are the different types of air masses, we need to describe them separately with their locations. So I just a quick explain a quick description again. I just wanted to say what are the regions involved in here. So in continental tropical, we have mainly Africa, a part of Asia, and the lower side of the full Asia. That means Indian subcontinent and others. A part of Australia and a part of South America and West Indies. These are the areas of continental tropical. Continental tropical, yes. And maritime tropical includes middle 0 to 30-degree latitude, south and north of Atlantic, Pacific, and also Indian Ocean. And if you go in the polar area, we have MP, polar maritime. We have only two big one. One is, there are a couple of other seas also, but mainly two big ocean. One is Atlantic, one is Pacific Ocean. And when we say continent, it is United States and Canada. And here is Europe and also Soviet Union, part of China, Japan. These are in the polar uh, maritime polar area. They have been fallen. And Arctic region is a different one, because as we see in here, but if you see this one, you can see the top of them is Arctic, and normally there is no population in here, but they can influence the air masses from its origins. Now let's see a description from the from a video, so that we can understand it more nicely. Mm, let's see that. Um, okay. Um, okay. Uh, can you see the video now?
Yes, sir. Weather bites.
Okay, thank you. Just to see what are the air masses that influence a country. Here it is. They are describing about the UK, Britain in here, because from different directions the air masses are coming, and what are the air masses are coming in here. They are going to describe in here, just to make you understand.
If you want to know about the weather, you really need to know about things called air masses. But what with it being see-through and all that, air is a pretty difficult thing to look at. So first of all, what exactly is an air mass? Well, an air mass is a name given to a large chunk of air that develops certain characteristics because of where it is on the planet. For example, air that sits over North African deserts is very hot and dry. We call this type of air a tropical continental air mass because it's in the tropics and it sits over the continental land rather than over the sea. With the right weather patterns, this air can come all the way to Britain. As it moves north, it has to cross the Mediterranean Sea, Spain and France, but it will still keep some of the dry and hot characteristics it originally had. So, a tropical continental air mass brings us dry, warm, and mostly clear skies. It might bring more than just good weather, as this sort of air mass can give spectacular sunsets and deposits of fine red dust on the ground if it's picked up desert dust from the Sahara. Another easy one to spot is a polar continental air mass, and the name describes exactly what it is. This air mass is called polar because it comes from around the North Pole, and continental because it travels over the land rather than the sea. If this air mass makes it to the UK, it could have come from two different directions, either from the east, moving south from the pole across Siberia and Eastern Europe, or it can come from the northeast, travelling across Scandinavia before it gets to us. This air mass brings some of our coldest weather in the winter. At the end of 2010, the UK was in the grip of a polar continental air mass, and temperatures plummeted to a very chilly minus 18 degrees Celsius in Wales, the lowest on record for November. On their journey to us, often across the North Sea, these sorts of air masses can often pick up enough moisture to create really heavy snow showers on the east coast. In Northumberland, on the 30th of November 2010, one of these air masses dumped 40 centimetres of snow. 40 centimetres. But what about weather with a journey over water? Any air mass that travels over the sea will change dramatically on its journey to us. Polar maritime air arrives from Britain from the northwest. It starts over northern Canada or Greenland, where it's cold and usually pretty dry. However, its long journey over the Atlantic Ocean means the character of the air mass changes dramatically. As the maritime air mass travels across the warm sea, the air is heated and moistened from below. Warming causes the air to rise, and as the air rises, it cools, condensing moisture in the air, forming clouds. When this air mass arrives in the UK, we tend to get a mixture of sunshine, rain, hail, sleet, and even sometimes snow. As we are so familiar with this sort of mixed weather, it's not a surprise to find out that this is one of the most common air masses over the UK. When we hear forecasters predict sunshine and showers, it's probably because polar maritime air is on the way. We've looked at 3 of the 6 main types of air mass we experience in the UK. When an air mass originates far from us, it'll change on its journey to us. A continental air mass moving over land may alter only a little, whereas a maritime air mass alters massively as it interacts with the sea. Some air masses don't take a direct route to us and will alter as they move over warm and cold seas. The most severe weather we experience comes when cold, dry air from the north clashes with the warm, humid air from the tropical oceans to the south. We don't have enough time to look at every possible air mass in this film, but we've had a look at the basic types and how they change. If you want to learn more about air masses or anything to do with the weather and climate, why not visit the Met Office website?
So this is all about the quick descriptions. So one thing is very important here. They have said that when the air masses have been traveling from one place to another, if the journey is very long enough and they are on this journey, if they moves on a different sets of land surfaces or water surfaces, they also change their behavior. For example, from these areas, when the from these areas when they moves all the way to the directly to the European countries. So this is very cold temperature in here, Greenland, Canada, and many others. And then from here, when they travel to UK, all the way to Atlantic, so this temperature is very cool, but when they moves on the top of the Atlantic, this is relatively higher temperature than the land surfaces. So when it is high temperature, so previously the air masses, they don't have enough, what I can say, don't enough humidity. And then when they moves in on the top of the Atlantic all the way along, because this is a great distance from here to here, all the way, they are again getting some humidity from here, because this is another type of the air masses in here. And thus when they come to UK, then all the characteristics which the poses from these regions, that means cold temperature and low humidity, they have been changed a little bit. On the other hand, air masses may not directly come through all the way along. From here, some of the air masses, if they wanted to come directly from here, some of the air masses, they can surface this way and come to here. So depending on the direction, and those directions also influences by the geographical locations. A good example is from our cases in Indian regions, because in the top of the India and Bangladesh, there is Nepal. And by the side of the Nepal, between the China and the other borders, then these areas has one of the great geographical barrier is Himalayan range in here. And as Himalayan range in here, so when one types of air masses move towards the Himalayan range, they can be characterized that by that type of the barrier. Maybe, for example, if maritime tropical air masses moves in that directions, uh, not maritime, maybe continental maritime continental maritime tropical air masses, if they move towards the Himalayan range, they have been carried up with a huge amount of the humidity and hot temperature. But if they just come to in front of the Himalayan range, their temperature has been dropped down, and that can create a different sets of environment in there, and their direction has been changed due to this big barrier. So that is a different case. But now we are discussing about the general characteristics of the air masses so that we can understand it. So basically, we do depend on the humidity from water, and the temperature is dependent on the latitudinal differences. So this is all about the air masses depending on the sources and its regions. It may have different other subsets, but we are not going to discuss that. We are only interested about the major classification. So now if you have any question regarding air masses, you can ask me, and then we're gonna start a new topics in here. Do you have any question regarding air masses? Anyone? Hello, can you hear me?
Yes, sir.
Okay, so if you don't have any question, I can move forward.
Okay, sir.
Uh, Now the question is, when air masses come together, because as I said before, air masses moves from one places to another, and they moves to another sources. Then what happened? So air masses can move different directions depending on the circulation pattern. So when they moves and join together, meet together, there are different sets of incident can be happened. So these separate air masses come together. Maybe they replaces by one another. Maybe they stay together. Maybe they change their characteristics or alter their behavior. This meeting is termed as fronts. When they come together, they bring up together, and they called fronts. And these fronts are basically four different types incidents can be happened. So they are named after cold front, warm front, stationary front, and uploaded front. We are going to discuss about that. Before we discussing, just see this map. This is a very surface weather map that can shows different pressure systems and different fronts, and they are also shows some of the pressures air masses in here. So these gray color line, as you said, this is right. These are the lines of the equal pressure system. For example, this one you see, uh, 1028. Okay, so as we know, the normal air pressure on the sea surface is 1013. So it is a little bit more. That's why it is named after high pressure zone. This is also high pressure zone 1020. This is also high pressure zone 1024. That means 1024. But in here, you see this is the low pressure system, which is 1000. So the millibar. So this 1000 millibar means this is the low pressure system has been developed in here. This is the pressure system. Now you see the color arrow. So this color, this red color means it is coming from an area which is much more warmer. So maritime tropical, that means the air masses has been originated in a region of the tropical areas. As we know, tropical region is very much warmed up during the years, and maritime means it can also possess a huge amount of the humidity. So humidity and hot temperature, and this shows this direction it will move. Okay. On the other hand, this blue color they are cold in temperature, and as it is produced originated from the continent, so they don't have enough moisture in here, but cold temperature, dry but cold. So these dry and cold temperate air masses, they remain in here in this area. But if you see this one and that one, they are coming from this way and they are coming from this way. So this is Atlantic, this is Pacific Ocean. These Pacific Oceans, when they are coming from polar region, they are cold, but they have little bit of humidity. On the other hand, from here, similarly, they have little bit of humidity, but they are cold in nature. Now, very interestingly, these are the fronts. I'm going to explain it now um, because this is a front which is associated with warm air. Okay, and this is a front which is associated with cold air masses. So when it is cold, it is like some triangle is denoted on its blue color. And when it is a semicircle or half circle, it is termed as warm front and red in color. When both of the air masses remaining by side, you see in here, warm and cold, they are termed as a stationary front. So a stationary front, I'll gonna explain it, but just to make you understand, if you see this one, this low pressure system, it has been created because these are a different types of fronts which cut off one another. That means, for example, if prevailing air here is warm, and now the cold cold maritime polar has come in here, and when it comes, these maritime tropical, that means the high humidity, they can be easily be condensed, and then the vapor can start it to fall as rain or snow or sleet. Okay, because of the cold temperature of from here, and it is also humid. So both together, this warm air mass, which was associated before with some humidity, they can fall on in here and create some precipitation. So that's why this green color is termed as rainfall, because it is very warm in nature. So they are shower, green in color. So this is rain. And further north, this pink, it is freezing rain or maybe sleet, because it is further north and these polar air masses is coming in here. And this white color area, which is much more associated with the polar coldness with little bit of the humidity. So they are actually looking like some sorts of snowing area. It can be also associated with many other characteristics, but this is normal explanation. On the other hand, if you see these areas, we don't have any shower in here, because there is no warm front coming in here. Whether it may be a little bit of a maritime polar air mass, so little bit of humidity somewhere in here, but they are not too much humidity so that they can be precipitated in here. So precipitation is very important, that they can also they can produced from those type of air masses which originated which associated with high amount of the humidity. So this is a normal weather map descriptions. Now we are going to describe about different types of air masses so that we can understand it very nicely. So when a cold front displaces the warm air, we termed it as a cold front. So this is an indication of the heavy precipitation or rainfall or snow or anything. And typically their nature is like that. So prevailing air was warm. Now they can change their behavior and turn to different sets of precipitation because of the cold temperature, as we described in here. Okay, so they can be turned, this humidity is turned to vapor pressure to liquid substances and solid substances, so that we can have some precipitation. And they're moving very faster, more than 50 kilometers per hour. So it is their movement also great. Okay. So now we can describe a little bit about their characteristics, typical weather condition with associated with cold front in northern hemisphere, how it's look like. So if you see, it is a temperature, the temperature is dropping down. Why? As I said, cold front when moves, they just displaces the warm air. So that means that warm air is going to that places is going to be colder. So that's why temperature is dropping steadily. The pressure is rising because this is a stable condition. Pressure obviously will be rise because more pressure means a stable condition. Low pressure means unstable condition. So when the temperature is cold, that means this is a stable in condition. So after a shower, after a rainfall or precipitation, the sky will be clear. That means there will be steady condition. So these are their basic characteristics of a cold front. On the other hand, if it is a warm front, that means a warm air masses that displaces the colder air. And in that case, we do have some precipitation, but not too much. So we can expect some drizzling or a little shower, fogs, or maybe sometimes a little bit slate or freezing condition, but not too much rainfall. And their movement is also very slow because in the by the downside, it was cold air mass, and that is displaced by the warm front, and their their slope is also very not too steep. This is 1:200, and their movement is also very slow, like 20 kilometer per hour. So what are their characteristics? Their characteristics is before it was cold. Now after the warmer air come, it is warmer again, and the pressure system slightly rise followed by the fall. That means after the rainfall, and the cloud which can be clearing with scattered different sets of clouds, and these clouds especially in summer and occasionally cumulonimbus in summer, they can create some precipitation, but it is occasionally, not every time. Precipitation can be happen but very light in condition, and in that cases your visibility is very nice because this is warm front and you don't have any foggy condition anymore, so you can get some clear view. Now, there is another type of front which has been associated with both the types of the air masses. So they come together, they don't displace one another, they remain by the side for a long time. We say this is a stationary front, and a stationary front is a stable condition. We say we don't expect many differences from them. On the other hand, there is another type of the front which can be originated from an occlusion. That means when one air mass come to another air masses, sometimes they cut off fully half or some sorts of from the another air masses. So when they cut off, they can be occluded. That means they can take some of them from others to cut off that one. This is also termed as occluded front. So occluded front is also very important because sometimes it can change the prevailing air condition to a different one. So they are termed as occluded front. If you see this figure a little bit about, you can see this is a satellite images and then we explained it. So this is a warm front, this is a occluded front because it has been changed its real characteristics which was before, and this is a cold front before. Now it has been cutted down, this one half of a little bit of the warm front. So they took this occluded front, has been created to taken up the portion of the warm front in here, so they can change their behavior. Okay. Even this is more clear in here. So this is they have been taken down. This is warm one. They cut off this cold front, cut off this one. Okay, they cut off this portion together in here, and then occluded front remaining in here. And that condition, when they change, so we can expect some precipitation in here, because the high humidity and low temperature can create some precipitation in here. Now again, just to make you understand, we can just visit our area, another video, so that you can understand it more nicely, about the fronts.
You may have heard weather forecasters on television talking about a warm front or a cold front approaching, bringing with it a change in the weather. But what are they going on about? What is a weather front, and how does it affect our weather? A weather front is the boundary between two bodies of air with different temperature and humidity. These differences depend on where the air has come from on the globe. For example, air sitting over tropical oceans becomes very hot and humid, while in contrast, air over the Arctic becomes very cold and dry. That's logical enough, but what happens somewhere like Britain, where our climate is neither tropically warm and humid, nor polar cold and dry? Over the Atlantic, these warm and cold air masses often meet. Just like oil and water, they don't mix easily and can become unstable as a result, giving us an active area of weather in which fronts form. When air masses first collide, it's impossible to know if we're looking at a warm or a cold front. It's only when one air mass dominates that we can distinguish between the two. If the warm air is stronger than the cold air, then this is called a warm front. You may have seen this on TV as a line with red semicircles along it. The semicircles point towards the cold air and the direction in which the front is moving. If the cold air has the upper hand, then it's a cold front, which is shown by a line with blue triangles along it. The blue triangles point towards the warm air and again in the direction of movement. But what is happening when two opposing air masses meet, and what kind of weather does each front produce? On a fine day, if you see a layer of very high cloud beginning to spread across the sky, usually from the southwest in Britain, it may mean that a warm front is approaching. Warm air is less dense than cold air, so it tends to ride over the top of the cool air it's replacing. This creates a vertical slope to the frontal system, with the front first being seen high in the atmosphere, miles ahead of the front at ground level. As the warm, moist air is forced to rise, it cools and water vapor condenses into water droplets or ice crystals. These form clouds that you see approaching, first as high cirrus clouds and then as thicker clouds. It's these interactions which form clouds. If you're measuring the air pressure as the front approaching, you'd see that it's falling. This is because the column of dense cold air above you is gradually being replaced with more and more warm and less dense air as the front moves closer. Layers of cloud also deepen and rain begins to fall. A warm front usually produces quite a long period of light and drizzly rain, with a shorter spell of heavier rain at the beginning of the front. The rain or drizzle will eventually die out once the front has moved through, but it will often stay pretty cloudy. You might think that a warm front would mean nice warm weather, but unfortunately that's not always the case. All that rain and loss of sunshine can mean that temperatures are actually lower than they were before the front arrived. So why is it called a warm front? Well, the cold, dry air mass has been replaced by a warm, humid air mass. It just doesn't feel much warmer. But what about cold fronts? Warm fronts are easy to spot because you see the leading edge of high cloud approaching on the horizon across clear skies. However, warm fronts leave clouds behind, and the following cold front sneaks in under the cover of the clouds. This makes them hard to spot just using your eyes, as it's difficult to see any changes that might be on the way. But remember that the pressure falls with a warm front because the air is less dense. Well, the opposite is true with a cold front. A cold front is a bit like a wedge. The air is colder and more dense than the warm air, and it scoops it up, causing the pressure to rise. And we can spot that using a barometer. So what kind of weather does a cold front bring? Deep cloud layers form as the warm, moist air is forced to rise and cool. These cloud layers produce lots of rain, often in bands, and these bands tend to be quite narrow, with heavy rain in them. sometimes with even hail and thunder. Once the front passes, there's often a dramatic clearance with blue skies, bright sunshine as the cold air descends as the front passes. Temperatures fall at first, but they may rise again when the sunshine appears. However, this sunny weather doesn't always last for very long because if the cold air is warmed, it will rise, or convect as weathermen say, and produce showery rain clouds such as cumulus or cumulonimbus. As we've seen, weather fronts can be complicated things and bring with them some very varied weather, which is one of the reasons we have such an interesting time of it here in this country. We've looked at how warm and cold fronts are formed and what sort of weather they bring. But if you want to learn anything more about weather fronts or anything to do with weather and climate, visit the Met Office website.
So this is a very short description, but there are a couple of very interesting things described in here. One thing is when the moves, for example, yes, just to look up. Yeah. So fronts, for example, for UK, this is UK. You see, this is UK. So they said when the front comes from another direction, and that means air masses come together. They come together and then they change with the other type of air masses. For example, as I said before, the cold air masses, when they replaces the warm one, just like this one, so when they replaces them, the warm air mass, it doesn't mean they created the cold environment together. It means they change the nature of a particular area. Obviously, that is cold, but that coldness worked differently. How the energy has been changed. For example, a cold air masses when just overpass with the warm one, yeah, they create a low pressure system in there so that the that humidity which was prevailing before, they can now be dissipate means they can turn to vapor pressure to liquid substances or maybe solid substances. And once that has been happened, that means the precipitation happened, then there is no humidity in the atmosphere, and then you can see the sunshine very nicely. So this is the basic idea, although there are many other different sets of factors involved in here, but this is very basic idea. On the other hand, when the warm front come and they surpass the cold one, warm, as we know that warm air masses, they are lighter, and normally they are on the top of the cold air, because cold air is wetter, they remain in the downside, but the warm air, they move very quickly, and they can also lighter. That's why in the upper stage they can be seen very easy way. And with this cold temperature, with this cold air masses, they can also be precipitate, but not too much, because their movement, because of their prevailing condition was cold, and not too much humidity was before in here. So we can only expect a little bit of rain, maybe some drizzle condition, or maybe a little bit of the freezing rain, it can be said. But many things can be evaporated in the colder air near surface, because of this coldness, because of this movement. So warm front and cold front are the many cases, and they are much more dependent on different other conditions also. But basically they are they says us which air masses give us what type of characteristics, how much humidity, how much temperature, and how that can be changed. Now if you see an interesting thing in case of our country, for example in Bangladesh and many other how can I show maybe in here it might be seen very nicely. I mean here. So now we can see some frontal activities in here. So some air masses which is coming from these tropical regions and directly goes to north. In case of Bangladesh, normally we do have air flow from south to north. Okay, and as it is coming from the tropical region, that means from the Bay of Bengal or maybe the Indian Ocean. So these air masses is much hotter, that means warm air associated with high amount of the humidity. They moves further north or northward. On the other hand, from during the winter season, we don't have these airflow which is coming from the Siberia and other regions from the north, and all the way along it come to Bangladesh and many other countries also here. But you see, there is no big amount of the sea surface in here. As there is not sea surface in here, and all the way this coming from on the top of the continental areas, they don't have any good amount of the humidity. But they are very cold. But they are very cold. So these air masses, when come to here, and these air masses they move in these directions, they come together and they don't actually have much of the humidity, so that there is no precipitation during the winter time in here. On the other hand, in summer season or in the rainy season, when the movement is passing from this way, we have enough rainfall in here due to high humidity. So frontal action also much more dependent on the season to season, location to location it can varies, and also dependent on some local environment also. In our cases, as I said before, Himalayan range has a very great influence on our weather system, because when the air masses moves, they can be obstacled by this this high mountain, and they move in different directions. They can also create some local variations in there. So this is all about the fronts. If you have any question, you can ask me about the fronts. Do you have any question? Anyone?
Sir, I
Sir,
have
can
a
you
question
Yes,
about air mass, sir.
yes, please.
Sir, do different air masses have definite uh, direction of flow?
Uh, Normally, yes. Sorry, normally yes, they have a definite flow, because they are also much dependent on the circulation pattern. For example, in case of our, as I described now, that in case of maritime continental flow, which is coming from the Indian Ocean to from the Bay of Bengal to Bangladesh, it is coming from south or direction, means south to north. On the other hand, those air masses which is coming from the polar continental area, okay, continental polar area or continental Arctic area, they are coming from north to south. This is always been happen. In case of that description, you can also see here that in case of Great Britain, some of the air masses which is coming from the left side of the Norwegian, they avoid Norway, Sweden, and everything, and they come all along by the side of that one and come to Britain. So this is how normally the air moves, but it can be also changed. But what I wanted to say, general or average movement is always same, depending on the season, depending on the location, and depending on the, obviously depending on the latitude. They are very much flow in a same directions, but they can be changed. I don't know I can answer your question or not.
Okay, sir, I understand, sir. Thank you, sir.
Yes. Is there any other question? If you have any question regarding today's class, air mass or fronts, you can ask me. In your exam, maybe it will come like what are the different types of fronts and how they influence one another. Or maybe it can be a question of what are the basic characteristics of uh, maritime polar. Even I can give the name of these small letter and capital letter, like what are the basic characteristics of MT or CT or C, like this. You should have explained with the location and its origin, where it has been originated. Is it okay for you?
Yes, sir.
Okay, so most of the information I got from different sources. I will upload that things, and you also get the information from the book I gave, Arens in 2009. You can also have some description from there. I took some images from that book, and you just read it, try to understand it, because this is very important for our weather phenomena, as I described in in this figure, that how it has been changed and how it can create some weather phenomena. So now if you have this information of particular location, then you can draw it and you can understand how that can be changed. Means in here you can see this is a high pressure system and this is how the air moves. For example, if this is a humid area, we can expect the humidity will move in here. On the other hand, if some cold air mass is coming from here, so that it can precipitate in here, it creates some deposition in here. So you can easily describe the weather pattern during the course of in this course. You can understand how it can be described, or if you see this map, you can describe by yourself. So if you don't have any other question, then I can just stop here for today, and maybe we can come back again on Wednesday. Is it okay for you?
Yes, sir.
Okay, so same time, in Wednesday we will come back again. Okay, thank you all. Thank you all again.
Assalamu alaikum, sir.
Wa alaikum assalam.